Okay, now we can go on with working this problem. So, let's check it out. The problem says phosphorus reacts with oxygen to form diphosphorus pentoxide. How many moles of diphosphorus pentoxide will be produced if 1.72 moles of oxygen react with phosphorus? The first thing I ask you to do is balance the chemical equation. So, phosphorus reacts with oxygen, which is a super 7, to form diphosphorus pentoxide. That is a skeleton equation. It is not balanced yet, is it? Knowing what you know about balancing, what's going to cause you problems here? Oxygen, because I have an even right here, and I have an odd right here. So, can this even ever be odd? No. Can this odd ever be even? Yeah. So let's make the odd even. 10's an even number, correct? So I can take this to 10, and I can take this to 4. So now, do I have a balanced chemical equation? Absolutely. Okay? See why I love these problems? Because it takes everything you know from day one to get to where we are here. Now that I have my balanced chemical equation, what do I know? What do I want to find? What do I know? That I have 1.72 mole of oxygen. 1.72 mole of oxygen there. What do I want to find? Okay. How many moles of diphosphorus pentoxide? How many moles of that? So I have my known, I have my unknown. I'm going to start with my known. 1.72 mole of oxygen. And I'm going to do a conversion box. What is that called? What am I putting in my conversion box? The molar ratio. Where do I get the molar ratio? Coefficients of the balanced equation. Now let me ask myself this. What do I want to cancel? Moles of oxygen, so where am I going to put that? On the bottom. How many? 5 mole of oxygen. What do I want to find? Moles of diphosphorus pentoxide. Okay, so what's going to go on the top? 2 mole of diphosphorus pentoxide. Do I get a cancel? Do I get a cancel? My moles of oxygen cancel. So my final label is going to be mole P2O5. Now, what am I going to do on my math? I'm going to take 1.72 and multiply it by 2, and then divide it by 5. And I'm going to get my answer to be How many sig figs? Let's throw sig figs back in. 3 sig figs. 0.688. Now, if you can't give me a thumb up, what questions do you have? Okay, I can't read your mind. I don't know what you don't get. So if I don't see a thumb up, who can be a thumb up here? If I don't give a thumb up, what's the question? Right, the question mark right here that I have is my unknown, what I'm trying to find. How do I know to get, once again, that's the molar ratio right here. This is the molar ratio. This comes from the balanced chemical equation. I put 5 mole of oxygen down on the bottom because here I knew that I wanted mole of oxygen to cancel, right? And when I go up here in my balanced equation, my molar ratio is 5 mole of oxygen. I knew that I wanted to convert this into moles of diphosphorus pentoxide. So when I do that, and I look up here, okay, here's mole of diphosphorus pentoxide. I come up to my balanced equation. What's my number that goes with that? 2. That's why I've got the 2 mole of P2O5 over 5 mole O2. Molar ratio, balanced equation. That is totally independent of this 1.72. The only thing we use is use this label to determine what goes on top and what goes on bottom. Divided by what I know. I multiply this and this, and then I divide by that once I get the answer. Okay? Now, I have a second one of these. So I'm going to give you a second. Write this down. Write the balanced chemical equation and try to solve it. Try to solve it. If you get caught, if you get hung up, raise your hand. I'll walk around. I'll help you. Okay, as I walked around, I saw some good things happening, folks. I saw some good things happening. The very first thing, once again, is I'm going to find the balanced chemical equation. And if you know correctly, I'm going to write the equation up on the top of this. Okay? What I did, folks, is I threw at you the exact opposite of the equation we used at first with the notes. We used the decomposition of aluminum oxide at first. Now we're using the combination reaction to form aluminum oxide. I don't know if you recognize that or not. Hopefully you did. Now, as I said, this is 2 different problems because it asked me to find moles of aluminum, 1, and then oxygen, 2. So this is 2 different problems. Does it matter which one I do first? No. What matters is I get it right. So, I'm going to take 7.38 mole of aluminum oxide do my conversion box, and since I have a number 1 up here for aluminum, I'm going to do aluminum first. My molar ratio is 2 mole aluminum oxide. I want that on the bottom so that it'll cancel. And on the top is going to be 4 mole of aluminum. I go back and I double check that I get a cancellation. Absolutely. So I take my 7.38, multiply it by 2, check. I take my 7.38, multiply it by 4, and then I get the answer and divide that by 2, and I get a number that has 4 significant digits. And I got to make that into 3 sig figs. So I'm going to have 14.8 mole of Al. First answer. Second answer. I'm going to go back to the 7.38 mole of Al2O3. Now my conversion box is going to be, on the bottom is still 2 mole of Al2O3, but on the top now is going to be oxygen, 3 mole of oxygen. Once again, I double check, do I get my cancellation to occur? Yeah, I do. So I know that my answer now is going to be moles of oxygen. I take the 7.38, I multiply it by 3. Once I get that answer, I divide it by 2, and I come up with 3 sig figs, 11.1 mole of oxygen.